Good morning, dear students. So we were doing distance formula, and up to fifth question we have done. We have to start from the sixth question. Okay, let's get started with it. So the question was the point A minus 5 1 on reflection in x-axis is mapped onto A dash, and A on reflection in y-axis it's mapped onto as A double dash. Now find the distance between the 2 points A dash and A double dash. So we need to reflect this A minus 5 1 as A dash in the x-axis. So this was A minus 5 1. We need to reflect it, on the x-axis. So how we will reflect it? Just put a mirror on the x-axis. Wherever this point will show its image, that will be the reflected point, or that will be you'll find the reflection of this point. Okay, so as you are reflecting with respect to x-axis, so your value of x-axis will remain same, but the y-axis will be 1, it will be minus 1, and it will be minus 5 only. Okay, so minus 5 and here it will be 1. Now if you want to reflect this A with respect to y-axis, so minus 5 1, what will remain unchanged? 1 will y will remain unchanged, minus 5 will become plus 5, so 5 1. Now you need to find the distance between this point. Okay, no need of making this in graph, okay, because we need only the distance between A. So distance between A double dash will be x1 minus x2 the whole square minus y1 minus y2 the whole square. So this will be minus 5 minus 5 minus 10 the whole square, that is 100. Okay, minus 1 minus 2 the whole square, that is 4. Okay, so what can you write? 104. Now factorize it, okay, and just see what you are getting. That will be your final answer. Okay, let us come to question number 9th. 7th and 8th, they are very easy. You can easily do. Just understand the situation and do it. Okay, so I'm reading the 9th one. The point A34 is mapped onto A dash on reflection in the line L1 parallel to x-axis. You need to reflect A34 as A dash. And how you will reflect? The given situation is there that with respect to L1, line L1, that should be parallel to x-axis at a distance of 2 units in the positive side of y-axis. So just see, this is your 3 4. You need to reflect in a way that it should be you have to reflect with respect to this line, and we are giving this line as L1. So let us give this L1 as this line as L1, and that should be on the that should be parallel to x-axis. So yes, it is parallel, and on the positive side of y-axis at a distance of 2 units on the positive side of y-axis. So I hope you have understood. Now how to reflect this? As we see that this is 2 distance, this is 2 units, so you need to count 1 2. Okay, the x will be what? Same, 3, and your y will change, that is 0. Okay, now this A dash, let us give this as A dash. A dash is reflected with line L2. You need to again reflect this parallel to y-axis. Now it should be parallel to this y-axis at a distance of 2 on the negative side of x-axis. So negative side of x-axis is this one. So drawing the line like this, okay, on x equal to minus 2, and we need to reflect. Now count how many jumps you require. 1 2 3 4 5. So 1 2 3 4 5. So at this point, matlab minus 7 0, this is A double dash. All right, so this is your A double dash. Now you need to find the distance between this A and A double dash. Can you find the distance between A and A double dash? Yes, minus 7 minus 3 the whole square plus 0 minus 4 the whole square. So it would be under root minus 10 the whole square plus minus 4 the whole square. This will be 100 plus 16, sorry, so 116. Now factorize this, you will get the answer. Okay, like this you have to do. Now how you will understand? You just make a rough diagram in the fair copy and try to don't do in the graph copy, not required. Okay, we just only need the reflections and all. It is not said that it is a graphical work. Okay, let us come to the 10th one. B1 I'm doing. Okay, so we need to prove that these three coordinates are the coordinates of equilateral triangle. All right, so let us consider, sorry, we have to prove. I made this lines. Okay, we need to prove it. It's not already proved. So A, B, C, given I have the coordinates, let us find AB. Okay, so x2 minus x1 the whole square plus y2 minus y1 the whole square equal to, this will be 0, this will be what, 2a. So 2a the whole square is 4a square, or directly square to root cancel, will get 2a. BC, okay, x2 minus x1 the whole square plus y2 minus y1 the whole square I did. As you can see, this 2a to 2a we can cancel, root 3a the whole square and 5a minus 6a minus a the whole square. This can be written as 3a the whole square, and this is a square. They both will get add and will get 4a square, which is 2a. AC, what will be AC? x2 minus x1 the whole square plus y2 minus y1 the whole square, like that. Here again 2a to 2a cancel, root 3a the whole square, we will get 3a square, and 5a minus 4a a square, this will give you 4a square, and we'll get 2a. Okay, so as AB, BC and AC we are getting 2a, all the three sides are equal, hence it is a equilateral triangle. So in such type of questions, 10a and 10th A1 isosceles triangle you have to prove. You know the property of isosceles triangle. Any two sides are equal and one side is some other, it will be unequal. So it will prove a isosceles triangle. And for third one also, again you need to prove for the equilateral triangle, which you can easily do. Alright, so let me just explain you the 11th B1. 11th A, as you can see that you need to prove that the three coordinates are the coordinates of the right angled triangle and find the length of hypotenuse. So how to prove that any triangle is a right angled triangle? So if ever you get this and this one, the three sides, so try to apply the Pythagoras theorem. Alright, in this question we need to use the application of Pythagoras theorem. One side, the square of one side will be equal to the square, the sum of the squares of other two sides. You take one side, square it. First of all, you take all the three sides, just square all these three, and try to check that on adding any of the two sides, are you getting the other side or not. So if you are getting with the ways, number of ways you will do after adding first, second, third, first, third. With this three ways, you will get one way where it is proving. So you can, from there you can conclude that yes, it is a right angled triangle. I'm explaining you the 11th B1, which in this you have to prove it is a isosceles right angled triangle. Isosceles right angled triangle means this side and this side should be equal. All right, this see, hypotenuse is hypotenuse is the longest side in the right angled triangle. Okay, so if they are talking about the isosceles right angled triangle, that means perpendicular and base will be equal. So let us prove it. 11th B1. Okay, so let us understand. Let the points be A minus 6 minus 8, B minus 16 12, and C as minus 26 18. These are points given in the question. Okay, so first of all, let us find AB. x2 minus x1, so minus 16 minus 6 the whole square plus 12 minus 8 the whole square. Minus plus, and this will be minus plus, minus 16 plus 6 minus 10, and this will be 20 the whole squares. So 100 and 400, 500. So in this 500 I'm writing under root of 100 into 5. 100 will go out, it will be as 10, and 5 will remain inside the root. Similarly BC, x2 minus x1 the whole square plus y2 minus y1 the whole square, minus plus, and as you can see I've done, this is the answer. For AC, again x2 minus x1 the whole square, y2 minus y1 the whole square. Okay, so like that I got. So this three answers. As you can see that wait, this will be 10 root 5. Okay, I've written just reverse. So as you can see that AB is equal to AC, which is the property of isosceles triangle. Okay, AB is equal to AC, which is the property of isosceles triangle. And also one more thing, if you square both of them and add it, you will get the square of this one. What will be the square of this one? Okay, square of this is 500. This square of this is 5. 500 is what? 1000. And square of it is 1000. So equal. So AB square plus AC square is equal to AB square, which is a property of right angle triangle. Hence, the both properties are matching. So we can say that triangle ABC is an isosceles right angled triangle. Okay. Okay, let us understand question number 12, B1. Okay, A1 you can easily do. Okay, just try to understand the B1, you'll easily get the A1 also. So you're asked that two vertices of the isosceles triangle are given, and you need to find the third vertex if the two equal sides of the isosceles triangle is given 3 units. Okay, so these two coordinates are given. Let us consider the third vertex be xy, and whatever equal, that is 3 units. So we cannot consider this as 3 units. Why? Because we can easily find the distance of this one. 2 minus 2 0, and 5 minus 0 5. 5 square is 25, root 25 is 5. So it cannot be equal to 3. So automatically this and this will be 3. Okay, if we have considered xy, so we need to let us find the distance between this and this. So AC will be x minus 2 the whole square and y minus 0 the whole square. Okay, keep it as it is. Find BC. BC will be x minus 2 the whole square and y minus 5 the whole square. As AC and BC equal, so make these two expressions, make these two RHS equal. So this here and this here, see y minus 0 the whole square, it became y square, and this as it is. We can cancel this root with this root, we are left with this thing. And again we can cancel x minus 2 the whole square with this x minus 2 whole square, because they are in the same sign and in the equal we can cancel. So you are left with y square and y minus 5 the whole square. Okay, now open the bracket, y square minus 10y plus 15 25. Again you can cancel y square with this y square. Take minus 10y here. So minus 10y equal to 25, or y is equal to 25 by 10 or 5 by 2. You got y as 5 by 2. Now you need x. How to find x? So just put the value in this AC. AC is equal to this. Alright. We have AC as 3 units. So substitute the value as 3 unit under root of substitute the value of y also, which is 5 by 2 the whole square. Now you need to square the both sides to remove the root. Okay, so squaring both the sides, this 3 9, this as it is. 5 by 2 square will be 25 upon 4. Now take minus 25 by 4 here, so 9 minus 25 by 4. Take the LCM, 9 4s are 36 minus 25 is 11 upon 4 is equal to x minus 2 the whole square. Okay, now I'm doing here, so x minus 2, it will be plus minus root 11 by 4, because whenever you just cancel square and put a root here, so whenever the value comes out to be 2 plus n minus 1 reason. What is the another reason for claiming this? This is a quadratic equation with highest degree 2, so there should be 2 values of x. Okay, so that is why we consider positive and negative. So for positive x, or for the positive sign, what will be the value of x? X minus 2 is equal to under root 11 by 2. We can take 4 out, take minus 2 that side, so it will be what? Plus 2. So one coordinate is what? 2 plus root 11 by 2 comma 5 by 2. Okay, understood? Now what will be the another value for negative value? For negative sign, what will be the case? X will be equal to, take this as minus, so minus root 11 by 2, and if you take minus 2 that side, so it will be plus 2. So what will be the coordinate then? 2 minus root 11 by 2 comma 5 by 2. So you will get 2 coordinates of this one. For the positive case it will be like this, and for the negative case of x it will be like this. Now I hope you'll do the homework. In the next video we'll just complete this exercise and this part also, that is of coordinate geometry, and we'll go to the next chapter. Till that, do practice. Have a nice day. Thank you. Bye bye.